So yeah, just if you remember last week and the week before, I did promise we would do the predicted paper that I made. So this is the 2023 predicted paper. So the way this works, so I just want to go through one thing, is that I have left a link in the description where you can like download these. They also come with like a mark scheme that I've made, which is what took a bit long. Just so you're aware, so you obviously have paper 1, paper 2. I'm not. This isn't anything new to you, I promise. Paper 3. Basically, because there's so much variation in like AQA papers, I've actually made 3 versions of each paper. So in total, there's 9 papers and 9 mark schemes. The only one that is on there at the moment is paper 1A. Okay, and over the next few days, I'm going to add B and C and also make the store look a bit, like the download page a bit nicer because it looks hideous at the moment. And then obviously I'll release paper 2 and then paper 3. The thing is, making exam questions is pretty, it's pretty tricky, I found, and it is quite a fun experience to actually do that. Because you have to like know the answer and then work backwards, because sometimes you get weirdness. So at the moment there's only paper 1A, which we're going through today anyway, so you don't have to worry about downloading that if you don't want to. But over the next few days, B and C will come out. Then we'll try and do paper 2 in the next week or 2, but again I have to like write all the mark schemes and stuff, and then paper 3. I have most of the papers made, it's just doing the mark schemes and also making sure it's perfect for you guys, because I want to make sure it's good quality. I don't want to just give you crap that doesn't work. So the questions and answers should actually work quite well. So yeah, that's why it's taken a bit of time. Bit more challenging than I thought, not gonna lie. I also had to like talk to the people that run the downloads page, which was a bit painful. That's a whole another story. But should we get started? I suppose we should. So it's a non-calculator paper, obviously. If words are hard, what we'll do is we'll go through it in order, or we can go through it backwards. So start from the hardest question and work our way up. But keep in mind that if you do download this, you get the mark scheme as well, which has all my answers on it regardless. So it doesn't really make much of a difference, whichever one you want to do. So should we start from the end or start from the beginning? The beginning is literally like the basic 1 markers. It's kind of up to you. In order, and ooh! Okay. What I'll do is we'll try and get through as much as possible. In the last, let's say, 15 minutes, we'll go to the end, okay? We won't get through the whole thing anyway, because it's meant to be like an hour and a half, hour and 40 paper. Okay, cool. So in order, so work out the value of, and we're given just a fairly simple thing. Again, it's non-calculator. It shouldn't be too tricky. 64 minus 37 gives you, not minus 3, minus 37 gives you 27. So then you have the cube root of 27 squared. The square of 27. So there's actually 2 ways to do this, right? Some students, when they found a question similar to this, they would square 27, then cube root it. That's not good. I would cube root it first, then square it. It makes it a lot easier. So you can either use your rules of indices to realise that this would be 27 to the power of 2/3, or you should know that you can actually square and cube root in any order. So if you cube root first, you get 3 squared, which is 9. Okay? So the tricky part with this question is some students, obviously they didn't do this question because this is a paper I've made up, but in similar questions, they squared the number and then tried to cube root it, which if you imagine trying to do that in your head, because it's a non-calculator paper, that's hard. You can cube root before you square the number, okay? That might be somewhat useful to you. Simplify 4 squared times 4 to the power of 3. Again, that's just 4 to the power of 2 plus 3. Hopefully nice and easy. Like that. Again, some students would circle like 16 as an example. 16 to the power of 5. I've seen that a couple of times. Let me know if I'm going too quickly, by the way. But bear in mind there is a delay on the stream, so like count to 5 and that's when I've seen it, and then count to 5 for it coming back. This would just be 4x, and then you're just plussing 2x plus 1. Good speed. Okay, perfect. 2x plus 1. And again, you can make note of any kind of interesting tips I give you, but you know, it might not be anything useful yet. 4x squared plus 4x plus 1, which, if you gather the like terms, is 4x squared plus 8x plus 1, which is first one so far. Okay. Again, actually I'll zoom in slightly more just while we do this so you guys can see it a bit clearer, because it is a bit blurry for me anyway, but I'm old. So 4 to the power of 3 to the power of a fifth, all that is the same as doing 4 cubed over 5. Now, what does this mean functionally? Well, what it means is you're actually taking the fifth root of 4 cubed. And which one says that? That is this one over here. Okay. Solving inequalities, again, something that comes up relatively frequently, but again, just I have 3 iterations of each paper that are completely different from each other. They have no overlapping questions, just to make sure you're prepared for any kind of paper they give you. But 3x plus 2, 3x plus 6, 4x minus 10. So bring the x's to one side, so 3x is smaller than 4x, so I want to minus 3x from both sides. So I get 6 is greater than x minus 10, plus 10 to both sides. You get 16 is greater than x, or you can write that obviously as x is less than 16. Okay. Again, just stop me the second you want me to go through something, but try and reference what question it is. Work out the percentage decrease from 360 to 90. So there are 2 ways to do this, right? This is a percentage change question. You can either do 90 minus 360 over 90, or over 360, sorry. Or, and that will give you a negative answer, right, which is fine. Or you can actually just flip it around and do 360 minus 90 over 360. It's the same either way, just one gives you a negative answer, one gives you positive, but because it's decrease, it should make sense your answer would be negative, right? It doesn't actually make a difference. So this would be negative 270 over 360. This would be plus 270 over 360. You can divide the top and bottom by 90. So if you just look at so get rid of the zeros. 27 over 36, you can divide the top and bottom by 9, which would give you 3 over 4. So again, we can just cross out the zeros. Divide the top and bottom by 9. And either way you get the same, well, you get the same answer, but just a different sign. But both answers are actually acceptable. And then all you need to do is turn that to a percentage, which hopefully you know is either negative 75% or it's plus 75%. But again, I know I've repeated myself, both answers are fine, right? Negative 75% just implies it's a decrease, but since they've asked for the decrease, you can just ignore the sign. So far I'm hoping so good. Next question, it starts doing the problem solving. So we have a recipe for chocolate chip cookies, brown sugar, butter, flour, chocolate. This is enough to make 6 cookies. So Robbie has 450 grams of brown sugar, 1 kilogram of flour, blah, blah, blah. What is the maximum number of people that Robbie can make cookies for? So here you're going to work out which one of the ingredients is limiting Robbie. So is it the chocolate, the butter, the flour, or the brown sugar? And then work out how many batches you can make based on the limiting factor. So that's a lot of words I just said. So what I like to do is go through one by one, right? So I work out brown sugar. Okay. Now, Robbie has 450 grams of brown sugar, and you only need 100 grams of brown sugar per batch. So this relates to 4.5 batches, which is equal to 4.5 times 6 people, right? So there's 6 people per batch. We can make 4.5 batches with the brown sugar we have. So in this case, we would have 4.5 times 6. So 4 times 6 is 24. Half of 6 is 3, so there'll be 27 people. Then we're going to go with the flour. Let's just read it in order. Robbie has 1,000 grams of sugar. and there's 160 grams, flour, 160 grams in the actual recipe. So that would be 160, 320, 480, 540. Okay. Hello, Ma. How are you? That would be 6 1/4, right? It'd be 6.25. So again, just for those people that have just joined, since we had a few people join, this is a predicted paper that I've made, based on like just the previous years, in particular before COVID, because as you know it's changed. I'm very well, thank you. And we're just going through it step by step. If I'm going too quickly, let me know. If you have any questions, let me know. But I'm just trying to show you basically the overall layout. Again, in the description you can download not only the paper but also the mark scheme. And there's also going to be, over the next few days, more papers and mark schemes added to it. But I'll go through that towards the end of the lesson, if that's okay. So then we're doing 6.25 times 6. So that would give me, 6 times 6 is 36. 1/4 of 6 is 1.5. So we'd get 37.5 people. But obviously we can't have that. So that's equal to just 37 people. Okay. No worries, Ma. 500 grams of butter, so let's just go through the butter. So that is another way to do it, yeah. So if you put it in a ratio and keep simplifying, so as in put these ingredients in a ratio. Oh no, as in like brown sugar to brown sugar. You can do that, yeah. That works. So this way I find more students kind of find a bit easier, but if you want to do that way, that's totally fine, absolutely. So keep going. Again, if you want me to skip this question, I'm more than happy to do that. But with the butter, you'd have 150, 300, then you need to have 450 and 1/3. So you have 3 and 1/3 batches. So you have 3 and 1/3 times 6. 3 times 6 is 18, and 1/3 of 6 is 2. So 2 add 18 would give me 20 people. And lastly, we have the chocolate. You have 300 over 80. So you can cancel that out. 30 divided by 8 would be 3 3/4, so 3.75 or 3 3/4. So again, you can call it 3.75 or whatever one you want. So 3 times 6 is 18. 1/4 of 6 is 1.5 times up by 3 would give you 2.5. It should give you, sorry, 2 people, so it'd be 22 people. So the limiting one is the butter, right? Which means you can only make enough cookies for 20 people. Okay. So again, a ratio, you could potentially use a ratio. Yeah, that would also work. Hopefully that makes sense. Okay. Again, just so you know, there's a delay on the stream. So if I scroll on, even though you've asked a question, it's just because I haven't seen it yet. We have the nth term of a sequence is 6n minus 3. The reason why it's 20 people is if you think about it, if you have a certain number of ingredients, you can only make enough batches for the minimum number of people. So for example, I have enough flour for 37 people, but only enough butter for 20 people. Now, those extra 17 people will have no butter in their cookies. So they'd be pretty disgusting. So you can only make enough batches for the lowest number of people, because otherwise you run out of ingredients. So in this case, the butter is actually the limiting factor. No worries. Nth term, so again, if you're writing the first 3 terms, the n's start from 1 and go on. So we're just subbing in n equals 1, 2, and 3. So n equals 1, we get 6 times 1 minus 3, which is obviously 3. So that's my first answer. N equals 2, we get 6 times 2, which is 12, minus 3, which is 9. And to be honest, you can just work out what the next one is. It's just going to be adding 6. But if you want to just write out the full working out, 6 times 3 minus 3, which is 15. Is it 18? Yeah, 15. So just adding 6 on to each time, so it becomes 15. The next question is something that is slightly trickier. So which term of the sequence is equal to 45? So instead there's a little bit of algebra. You have 6n minus 3 is equal to 45 because that's what you're trying to work out, right? Then all you need to do is rearrange for the n. So add 3 to both sides. I'll go back up here. Then you divide both sides by 6. You get n is equal to 8. God. Which means it is the 8th term. Pretty fast so far. Okay. Bill says 645 is in this sequence. Is he correct? Yes or no, and then explain why. So what you'd want to do here is, again, you set 6n minus 3 equals to 645. So 6n equals 648. And n equals, and you'd have to do 648 divided by 6. So there are a few tricks I can show you here, right? Is 600 divided by 6 is 100. Yeah? 48 divided by 6 is 8, so it's just 100 plus 8, which is 108. Because we got a whole number, it must be in the sequence. If we got a decimal or a fraction or a remainder, it won't be in the sequence. So far so good? I am going a bit quickly, but that's just because I want to make sure I get through as much of this as possible to kind of help you guys out and what I think the paper will look like. But when we get to the end of the lesson, I'll explain a few more things about what we're doing. This was a question that a few people kind of struggled with before, but I do expect them to have depreciation in the non-calculator paper. Okay? So again, a lot of the times, even when I said it, I think, interest and depreciation has been a calculator paper, but they can put it into the non-calculator paper. There's no reason why not, and I have a suspicion they'll do it this year. So this diagram shows the value of a car, £22,300. She purchases it for £22,300. Hello, hydrocarbon, how are you? And the value of the car depreciates by 20% each year. So what is the value after 2 years? So of course, when we normally do depreciation, you take the amount, times it by the percentage, and then to the power of number of years. But without a calculator, that's pretty damn tricky. So instead, what you're going to do is work out what it looks like after the first year, and then the second year separately. Okay? So first year, it goes down by 20%. So all you need to do is work out 10%, which you just get rid of a 0, is 2230. So 20% is double that. So 4460. It's going to lose £4,460. How would you know? Okay, good question. So depreciation is always compound interest, so to speak. And in the question, they'll tell you if it's compound or simple interest. They have to. Okay? So in the question, they will literally say compound or simple interest, but depreciation, you always treat it like compound interest. So all we're going to do here is we're going to do 22,300 subtract 4,460. So again, this, I imagine this is a relatively easy thing for you guys to do. 4, 8, 17,840 pounds after the first year. Now in the second year, this is the new price. So you're taking 20% of that new price. That's the key thing about compound interest and depreciation. So again, be careful with that. I think that's where they're going to try and catch you out. And as Mar said, they might try and catch you out by making you think it's simple interest. So find 20%, double it, and then take it away. You'll get a different answer. So again, 10% in this case is 1,784. 20% will be double that. That is a bit tricky to double, but it would be £3,568. Yeah, cool. So again, we're just going to subtract it once more. So again, that's where I think they're going to try and catch a few people out. And it's a fairly easy mistake to make. So you can't do that. So 3, 1, that makes it 2. Cross that one out, 7, 1. That is a 3, so 13 minus 6 doesn't really look like 1. 7 minus 5 is 2. 4, 1. So your final answer is £14,272. Okay. Hope that makes sense so far. But again, I do suspect that they'll put what should be compound interest into the non-calculator paper this year. I have a feeling. Because I haven't done it before, really. This is also a fairly interesting question. So it's a more complicated ratios question that I expect them to put something similar in. If you guys have done, it was either last year or the year before, it was actually an Edexcel paper where they actually had a fairly tricky question in terms of black triangles, black circles and all that stuff. In fact, we did it on the live stream. In Tricky Questions Part 1, we did that question. It's somewhat similar to this, so they're actually kind of leaning into doing more difficult ratio questions. So this is a ratio question that I kind of came up with. Yeah. So this is a ratio question that I kind of invented and modified. I think this might be something similar, or at least the skills we use here will be similar to what they do this year. So, how do we do this? X to Y is equal to 5 to 2, right? And X plus 7 is equal to 49. So, basically, this is our total. Right? Now it tells me that X to 7 is 5 to 7. So X is 5/7 of 49. That makes sense? So X plus 7, that means the total parts equal 49 things. And X is 5/7 of that. Hope that makes sense. So you're going to divide both. I actually haven't gone through where you get the marks from. Okay, I'm going to start going through where you get the marks from. So 49 divided by 7 is obviously 7, times by 5 is equal to 35. Hello Charles, how are you? And that means Y obviously equals times 49, which again is 14. Okay, so again that can be somewhat tricky. Then you get a mark for actually substituting. Whoops, 35. Okay, you guys can't read that. 35 times 14. That's a mark. And the final mark is for actually working out the correct answer. Which you'll have to, I mean, you could probably do it without it, but, you know, those of you that might not be able to, you have 4 times 5, which is 20. 4 times 3 is 12, plus 2 is 15. Then you have 1 times, 0. 1 times 5 is 5, 1 times 3 is 3. Sum it. You get 0, 0, 5. Unless I made a... I did make a mistake. No, I didn't. Yeah, okay, that's good. 500. I did that very quickly, so I may have made a mistake. But I hope not. I did, didn't I? Dang it, it is 490. Yep. I did that way too quick, that's my bad. It did look a bit weird. It's 490. Thank you, Evie. How would you know that's what you have to do, if that makes sense? I'd never have thought of doing that. Yeah, so that's actually why I did the predicted papers, Mar. Because a lot of the times they throw in they intentionally do this. 10% of your marks overall have to be from unseen questions. That's what Ofqual have said. And what they do is they put you in situations you've never seen before. So I know you've seen those questions where we've done like we did last week, where we had like 2 circles and we had to work out the area of that weird shape between them. So basically anything to do with like circles, there's really difficult questions. Even the ratio question they had a few years ago, it's not something you'd think of, right? I completely agree with you. It's very tricky, but it's designed to stop. It's basically like literally grade 9 plus work. So that's why I've actually done these predicted papers, to hopefully give you an idea of what kind of methods you can use, so that way you might be able to scrape some marks together in those beefy 5 markers they chuck at the end. But how do you know to do that? Well, as a teacher, I know that when you add the two parts of a ratio together, you get the overall total. Also, I made the question, by the way. That's how I knew to do that. It's kind of a big bonus of being able to make questions. And that's how I would have done that. I think this part is intentionally here to confuse you as well. But, yeah. So yeah, that's why I'm doing this whole thing. That's the whole point. Because I've got a feeling they're going to try and be really dodgy this year. Because it's the first year you guys are going to have proper exams. So every other year has had, like, since COVID, has had special considerations, changes to the content, stuff like that. This year it's going to be proper stuff. Okay? Which means they're going to come back swinging. Work out the sides of angle x. So, as you can see, you're going to use trigonometry. And you have, this side is your opposite, this side's your hypotenuse, SOHCAHTOA, exactly, we all know what it is. So again, not too tricky. Cos, good, because we have adjacent and hypotenuse, right? So that means we're going to be using, so just so you know, SOHCAHTOA. We have A and H, so we're using this one. So that is cos x is equal to adjacent over hypotenuse. So what that is cos x equals 6 over 12, which is a half. Now, I've told you before that you need to know certain values of cos x. Like, for example, you need to know 0, 30 degrees, 60 degrees, etc., right? So you need to know it backwards as well, if that makes sense. So not only do you need to know that cos 60 is a half, you need to know that a half would give you cos 60. Okay? That is the thing that I think they're going to chuck in here, because they're annoying. But hopefully you should know that you need to know certain values of cos. You need to know 0, you need to know 30, and you need to know 60, you need to know 90. Yeah? So you need to know them the other way as well. So cos 60 is a half is what you need to know. What they're testing here is you can recognise that backwards, cos of something is a half, it has to be 60. I'm pretty sure they're going to chuck something like that in. Yeah, oh yeah, and 45. Yeah, I missed that one out. Thank you. Yeah. So that is something I do expect them to do. Okay. How long have we got left? Ooh, still got over 30 minutes, not bad. We're not halfway through the paper though, it's kind of annoying. This is, I'm going to zoom out slightly so we can see a bit more of the data. Table below shows information about the wait times from a sample of 50 people for fast food delivery service. The statements are about the mean, median and mode of the actual times. This one's going to be a bit tricky for me to explain, so I might have to go through it a few times. But the key thing to notice here is most data is less than 20 mins. Okay, so what does that mean for your mean, median and mode? Well, all of them should be less than 20, right? Because most of the data is below 20, so your median should definitely be below there. Your mean should be below there. The mode is tricky because we don't really... You're going to get a range. You can't actually get a specific mode unless you have the actual data. So the mean could be less than 20 minutes. 100% true, because most data is below 20 minutes. So when you add them all up and divide them, you should get a number less than 20. The mean could be more than 30 minutes. Well, no, because again, most data is below 20 minutes. The mean could be less than 30 minutes. Well, yeah. If it could be less than 20, it could be less than 30. Again, please let me know if it's tricky. This one, the median is equal to the mean, might be somewhat interesting. Somewhat. The median is only ever equal to the mean when you have, how to best put it, uniform data. Do you guys know what I mean by that? So what I mean by that is there are an equal number of values. How best to put it? Okay. Let's say I have this data. The mean and median will be 3. Oh no, actually, let me put another value on. Will be 3, right? Yeah, median is the middle number when you order them. However, if you have an equal number of data below and above, actually no, I'm not explaining this very well. Okay. Again, I'm going to do the 1, 2, 3 thing, right? So as Lila said, median is the middle number, but the mean is actually somewhere up here, right? Because these three numbers, when you add them together, are bigger than these three numbers when you add them together. So the median is only ever equal to the mean if the numbers below the median add up to the same value as the numbers above the median. So that's called uniform data. So that would be false. Basically, in 99% of cases, it's going to be false. So again, you have to have the same kind of distribution either side, if that makes sense, right? Yeah, sure. So, okay, how best to put this? Wait, I actually have a calculator. Let me just. Okay. So, I'm just going to type something on the calculator just to kind of illustrate it a bit better. Okay. So, is this in terms of the classes as a whole? Okay, let me put this another way. In this case, the median and the mean are the same value. The reason for that is the data is equally spread out. Okay? Now, if this side was something a bit more crazy, so at the moment it's the same. Why? Because I have an equal spacing on this side as this side, right? So what I mean by that is if I look at just these three values and I take the range, so 2 minus 0, I get 2. If I take the range of the values above it, I get 2. Because of that, the mean is equal to the median. So it would be in terms of the classes as a whole, yeah. Yeah, in this case it would be out of the classes as a whole, right? However, let's say I have data that looks more like this. Actually, I don't need another value, sorry. Actually, I do, yeah. The median is still here, right? It's still the middle value. But the mean is somewhere over here. Why? Because the range here is still 2 minus 0 is 2, but the range over here is 20. It's 10 times bigger. So in short, the only time you're going to have the median being equal to the mean is when you have uniform data. So the range is just equal everywhere. So the range between any 2 points is the same. Yes. If you want, you could work out the mean by hand and you can work these out. The thing is, it's 2 marks. And also, it's a non-calculator paper. So you can do that. If you're able to do that, then more power to you. But that's tricky. Okay. So in this case, would the median be an inaccurate measure? The answer to that is, well, is it true or false? Well, it's a bit subjective, right? But generally speaking, you don't want to use the median if you have extreme values. Do we have any outliers here? We don't have any outliers, right? All of the data seems reasonable. We don't have another class down here that only has one person in it. So in other words, it's not an inaccurate measure. It could be accurate. And lastly, the median is greater than the mean. Well, using my weird example over here, there are more values below than above. So, I mean, I can't tell if they're going to be evenly distributed, so you can just say false. It's false because we can't tell. That's a key thing in these true-false questions. If you can't tell, it counts as you don't know. It's normally outlier, Lila. In maths, it's normally outlier because the data is just away. But you can call it an anomaly. It's completely fine. That was a pretty funky question. Okay. Next one. Again, another ratio question. In the past few years, ratios has been a big weak point. You did it by simultaneous equations. Yeah, if that works for you, yeah, that's fine. That is a valid way to do it. So, the reason why they're focusing so much on ratios recently is because students are doing really badly in ratios. So, that's why this has quite a few ratio questions. Again, I used examiner reports to help out with this as well. So Tina and Rosie shared £565 in a ratio of 3:2. Tina lends Rosie some of her money, so they now have the same amount. How much did Tina lend to Rosie? Best way to do this, in my opinion, is to work out how much Tina gets, work out how much Rosie gets. So in total, we have 3 plus 2 parts. Yeah? Which is 5 parts. So this £565 is being split into 5 parts. So what we want to do is do 1 part equals 565 divided by 5. You can use bus stop method, or you can use the little trick I sometimes use. To divide by 5, divide by 10, so 56.5, and then double, which would give you £113. Okay? So then Tina gives you 3 times 113, which is £339. So by the way, this would give you a mark here. Rosie gets what's left over, but you can also just do 2 times 113, which gives you £226. That's another mark. Now, for them to have the same amount of money, right, they have to basically meet in the middle, right? So what that means is we're going to take half the difference. Amount to lend. There are 2 ways to do this. It's either half the difference, which is the same as just finding the midpoint. So what you can do here is you do 339 minus 226. So this gives us the difference between their amounts of money. Right? And now they need to, what's the word I'm looking for? They need to give half of it away, right? They need to meet in the middle. So then amount to lend, 113 over 2, which is £56.50. Again, you can use the bus stop method if you need to. I'm just trying to go relatively quickly so we can get through as much information as possible. Does that make sense? Hope so. And my voice is going from trying to speak too quickly. Okay. Always use trial and error. Yeah, I mean, if trial and error works, that's okay. But you can't get method marks. Oh, by the way, this is the last. That's also the last thing. Okay. Information about the scores. Okay, I misread that question completely. Here is some information about the scores of 100 students on test. Complete the cumulative frequency table. So again, we're going to have I'm just going to call it C frequency, just to save space, cumulative frequency. And again, what you're going to do is literally copy over the exact same boundaries. Okay? So all of these class boundaries here, these groups, will just go here. Okay? And again, I'm just trying to save time. Now, cumulative frequency just means the frequency up to that point. So all you do is you take your values over, And then all you're doing is adding the next value. So 14 plus 6, 20. Then you add 47 to it, 67. Then you add 22 to it, 89. Then you add 9 to it, 98. And then you add 2, 100. So a good way to check your answer is to simply, it tells me the total is 100. Your last cumulative frequency should be equal to that number. I'm going to go on to drawing it, but again, make sure you just tell me if you need to. Draw the graph, okay? So the way you draw the graph is you plot at the midpoints of the classes, okay? So you take the midpoints, so in this one it'd be 45, then 55, 65, 75, 65. Now there is something to be said that some of you may have been told to plot at the upper limit of the class boundary, right? If it's cumulative frequency. Sometimes that's okay, but I would always plot at the midpoint, okay, just to make it super clear. So 45 and 6, please bear with me, this might not be the best. So what does it go up in? Well, we have 1, 2, 3, 4, 5 squares, and there's 20. So 20 divided by 5 means each small square is 4. So 4, 8, and we're, sorry, is it 45, which would be 1, 2, 3, 4, 5, so here, and we're going up 4, and it'd be halfway in between. Again, it will be easier to do this on paper. 55 and 20. '65 and 67, yeah, it's going to be a fun one. So 64, 68, so we'll be just below here. So, no, you wouldn't lose marks. You wouldn't. It's just, to keep things simple, you can then plot the frequency polygons and the cumulative frequency graphs in the exact same way by just always sticking to the midpoint. That's why I would recommend it, personally. But I've never seen anyone lose a mark because of it. 89. If you've ever seen a real mark scheme, they tend to not actually draw the graphs for you, and they just say like plotted correctly. So what they mean by that is it can be either. Otherwise, I'd have to give two graphs, which they're too lazy to do. 75 and 89. So 84, 88, so ever so slightly above 88. Again, it doesn't need to be a work of art. 95 and 100. So 95. And the way you join this is you actually quite literally join dot to dot. Okay, so I know a lot of the time in maths we don't join dot to dot. I like to make it really jagged and obvious. So I like to do this, pen off the paper, and again you'd use a ruler. So don't do what I'm doing, I'm being a bit... Yeah, mine looks a bit curvy, but you want to join dot to dot, okay? And just go like that. Again, it doesn't need to be a work of art, right? It's 2 marks. You get a mark for your points being plotted correctly, in air quotes, and another mark for your overall shape, so joining them dot to dot. Okay? Hope that's okay. Next, some more kind of indices stuff. Hopefully it's not too bad. So, the reason why we don't join it to the x-axis yet is because it doesn't start from 0. Right? So, if for example, if I did do this, right, how will I know how steep it is? Like, where do I join it? Or do I join it here? So again, unfortunately with graphs, it's a bit subjective. So personally, I wouldn't mark you down if you joined it. Because I get your point. It should start at 0, right? At some point, because there will be a 0 point. But again, in the mark scheme, if you read it, it will say points plotted correctly, right? And correct shape. It doesn't really give you much advice on that last bit, like you said. But I wouldn't do it. Just like with the frequency poly... Actually, no, sorry. No, ignore what I just said. That's stupid. Cool. So here we have 3/12 over 3 to the 6 to the 4. So again, you want to do the brackets first. When you have an indice to the power outside of a bracket, you multiply. So 6 times 4, which is 24. When you divide two things, you subtract their indices. And that's my answer. But wait, it says a fraction. So that would just be 1 over 3 to the 12. Like that. Nice and quick. Sorry, my voice is actually going in a minute. 16. Oh, one of the rules of indices is that if you have a negative, it makes it 1 over. Yeah, I did go a bit quick, so that's my bad. I will admit. The next thing that they always test in paper 1, or at least they used to until COVID came along. So just so you're aware, for 2020 or 19, I can't quite remember off the top of my head, they took surds out of the spec. Okay? But that was temporary for COVID, right? It hasn't made much of an appearance since, but it definitely used to be in there every single year. So I'm guaranteeing that they will give you surds. So we need to write root 60 plus root 81 in this form. Now root 81, I can just write straight away is 9. Easy peasy. Now, root 60, what they want you to do is what they want you to realise is you can write this as something times 15. Yeah, I didn't think it did, yeah. Okay, good. Thanks, Mar, for confirming. As 4 times 15. So why did I pick 4 times 15? Well, my answer has root 15. So I want to put this here. This can then be written as root 4 times root 15. And of course, root 4 is just 2. So that's what they're trying to rely on you being able to do. You get a mark for the final answer, and you get a mark for doing this. Splitting the surd. So if this confused you, I would recommend that you go and have a look at surds, because again, it hasn't come up in a while, mainly because of COVID, but it used to come up all the damn time. So if they're oh god, my voice. Ofqual literally said they want to get back to pre-COVID exams. That's what they said to teachers. So, yeah. I have a very strong feeling that they're going to do surds. Very strong. The next thing I expect them to do is the classic expand a triple bracket. As far as I'm aware, so basically the last thing Ofqual said to my maths department, and again it could be thing, is they said that you are not guaranteed to get a formula sheet. Okay? Not guaranteed to get it. Maybe more. But they literally did say to maths teachers, they're not guaranteed to get a formula sheet, so don't tell them that they get a formula sheet. Exactly. Now, they have said they want until the end of January to make a decision on whether you get one. But they've made it very clear to us, when they spoke to us, that you're not guaranteed one. So I'm thinking they're trying to lean towards getting rid of the formula sheet. Back in pre-COVID days, there was no formula sheet. At all. So, to be fair, there's not that much. Maybe, but on that I can't actually predict. I can't actually tell you if they will give one. No, not same for science. Not same for science. Science, you get formula sheets. Even just for the constants, right, that you need. So yeah, science you should get formula sheet. But yeah, no guarantees. If you want to say you get one, yeah, maybe, right? But not guaranteed, okay? But the fact that they stressed it, I think, means that they're... I mean, why would they stress it unless they wanted to push towards it, right? So, up to you. In the interest of time, do you want me to expand the triple bracket, or are you guys okay? Again, I don't mind doing it. In the last 10 minutes, what I could do is, instead of answering questions, I could go through why I put it in there and why and what makes sense. Oh, hey, Alia. Just go straight to the back page. Okay. So just for the rest of you, do you want me to just kind of go through and talk through why I think each part is in here? Or, okay, just go straight to the back page. Okay. I don't think the last few pages will be that tricky this year. So, yeah. So this is the last question. Something similar to this. I don't think it's too tricky. I think it'd be a relative softball. The reason why is because we've done a few things earlier in this paper which count as unseen. Honest, yeah. So, okay. You know, in the final few questions, that they sometimes are really, really difficult. That's only because they haven't done the unseen stuff during the paper. If they do the unseen stuff during the paper, they don't need to make the last page hard. Right? They can make it something somewhat easy. This is another thing I reckon they'll do. This would catch a few people out, I think. A few. Potentially. Also, so for those of you that are here, I would like to ask that you stay until the end of the lesson, because I do have some more stuff to talk about here. So what you'd want to do is you want to do that the total angles inside a shape. Good, yeah. So it's a 5-sided shape, so it'd be 5 minus 2. We can. It might take me a bit of time. Okay, so this formula here gives you the total interior angles of any shape, right? Any n-sided shape, right? So for a pentagon, it's a 5-sided shape, so you have 5 minus 2 times 180. So you have 3 times 180, which is 540. So all of the angles inside the pentagon should add up to 540 degrees. The reason why they consider this a tricky question is so many people... Quadrilateral. Okay, fair enough. Is so many people forget this equation here. Yeah? If you remember that equation, this question's guaranteed. Add it all up, equal to 540, you're done. Okay. Next, classic angle rules. Classic. A general vector question. If you send me it, yeah. If you send me it, I'll try and squeeze it through. Yes, that's for the interior angles. And it comes up relatively frequently because people forget about it. Actually, infrequently, which is why I think they'll use it this year, to catch people out. Then, yeah, I think it's going to be a classic case of using angles, so F angles and... what is the other thing? Circle theorems, things like that. Although this isn't too tricky of one. That's maybe. Oh, fair enough. Oh, the proof question, yeah? Cool. I mean, don't forget, circle theorems have to come up every year. And angle rules have to. This... It was really common before COVID, then they took it out for a couple of years. But I think they'll use something like this. Yes, I fully agree with you. Once you do it once, you're able to do it an infinite number of times. It's not too tricky. Every past paper, really? Oh, maybe I'm misremembering, but yeah. This is for AQA, but I would like to point out that AQA and Edexcel are very similar. Very similar. In fact, you can sometimes predict what comes up in AQA or Edexcel based on the previous year's AQA or Edexcel paper, because they communicate and things like that. Again, kind of like a comparing cost thing. So we have 5 more minutes, so I'd like to go through exactly what this is. Could I do an Excel one? Absolutely. This is actually what I was about to speak about. So, we didn't get through the whole thing, but just so you're aware, For Edexcel, so at the moment this is for AQA, right? I have the exact same thing for Edexcel. Okay? I do have it. Now, in the link in the description, you can currently download Paper 1A and its mark scheme. So all of the questions, all of the answers, right? If you spot a mistake, let me know. You can email me or message me in the next thing, because it was a bit painful to do it. Over the next few days, I'm going to give you the other two variants. So what's the difference between A, B, and C? Well, when I did my research for like putting these papers together, there are kind of a few patterns that I saw. So these three papers are they're completely different. Completely different. Okay? 100%, 1000% different to each other, right? But they'll give you basically all of the variations I think could come up. Okay? Now, the real paper could be a little bit of paper A and a little bit of paper C or something like that. Right? It could be. But they're all completely different to each other. So this will happen in the next week or so, the other two versions of this. By the way, the current link does look ugly. I know that. I'm working on making it look pretty. But it looks ugly at the moment. Because I had to kind of rush to get this done because I really wanted to get you guys this stuff as soon as possible. Paper 2 and 3 would take a bit longer. Okay? But I aim to get it done within a month. For Edexcel, I actually have... So there's 3 versions of Paper 1, yeah. But they're complete papers. I don't know about that. The actual store page looks a bit ugly, I'm not going to lie, and that's fine. Now for Edexcel, I actually have all 9 papers ready. All 9. Paper 1, 2, 3, A, B, C for all of them. They're all done. I started with Edexcel because at my school we do Edexcel GCSE maths. Right? And I started the AQA ones mostly for you guys because I know most of you guys do AQA. But I have the Edexcel ones done. However, I would like to point out, and I've said this many times in the previous videos, Edexcel and AQA papers are very similar. So, you can stick to the one whatever exam board you want, right? It's not so much my website. It's like a store page. It's the only way I could think of to actually give it to you guys reasonably well. Because if I just put it on my website, there's weird like security issues and things like that. This way, you know it's verified. You know it's legit, and also you can get like guarantees for it and stuff. It's £1.50 per paper because unfortunately there's a minimum price for these store pages. I couldn't make it free, which is annoying, so I put it as the minimum price. Again, I'll see what I can do about like lowering it or something like that. But yeah, at the moment only paper 1A of AQA is on there. Edexcel and the rest of paper 1 I'm going to hopefully get done by next week. Paper 2 and 3 I hope to get done by the end of the month. But unfortunately there are exams going on at the moment. I had to invigilate and it took up a ton of my time. An incredible amount of time. But that's my aim. Okay? But again, if you run out of AQA papers, do Edexcel papers. If you run out of Edexcel papers, do AQA ones. They're very, very similar. And they communicate with each other all the time. So it's good. I'm not just saying like, oh, buy also these ones. Like literally, if you're doing past papers, do the Edexcel ones and AQA ones. Where you just find it. But yeah, at the moment it's just paper 1A. It looks a bit ugly, as in the actual page. But it is all legit. Okay? And yeah. I really appreciate that, Evie. I really do. I did underestimate how long it would take me to do the AQA ones. Old spec papers, absolutely. 100%. So what Marja said, old spec papers, absolutely. Think about the maths you're doing, right? Algebra, trigonometry, circle theorems. These were made 3,000 years ago. They haven't changed. So feel free to do those questions. They are 100% accurate to what you're going to do now. They will look very different, right? But they're accurate. Okay? But yeah, the maths hasn't changed in thousands of years. The ancient Greeks made algebra and trigonometry. It's not going to change anytime soon. In fact, I think the actual geometry stuff we do is about 2,300 years old, if I remember rightly. It's from a guy called Euclid. Nope. The Edexcel papers aren't on your page. Yeah, so the Edexcel ones aren't on there at the moment. It's just the AQA paper 1A. I'm hopefully going to get the rest of them uploaded in the next week. I had some issues with uploading the I had to speak so not a lot of people sell these papers through like Shopify and things like that. So I had to like speak to them and say, hey, this is what I'm doing. Can I please do this? But yeah, I'm aiming to get paper 1A and Edexcel ready. What I'll do is once they're ready, in the next video I'll tell you they're ready, but I'll also do like a post. So you know how YouTubers can like do like comments and posts and stuff. I'll do that when they're ready. But I'll also talk about it in the next video too, if it's ready. Because I know that some of you won't see the actual post, right? Because YouTube is a bit packed. In fact, I think you only see YouTube posts on the mobile app. I've never seen one on the desktop version, so yeah. I'll tell you in the next video, and I'll tell you via a YouTube post when the next ones are done. True. I'm actually looking into doing shorts now. So I actually recently made an Instagram. I know, very exciting. But I'm actually going to do shorts as well. Because sometimes we go on these long rants and they might be useful to some people. But yeah, I'm going to do shorts as well. So I hope that makes sense. I will do shorts as well, yeah. Keep in mind, some of my shorts will be recycling content that you might have seen already. In terms of like the little snippets of stuff. But I am trying to make some more interesting shorts. So what kind of shorts would you like to see? That's the thing. Like 30 seconds or less. It can be a bit tricky to kind of go through. Tips? Yeah, fair enough. Okay. Tips. Okay, so I was just writing that down for myself. So next week, what would you like me to do? Should I go through like one of the Edexcel papers maybe? I could probably do that. Or again, they should be uploaded by then. It does depend on if I actually manage to get them done. Again, because it's like an exam season, believe it or not, I've been pretty busy. I haven't had as much time as I would have liked with people panicking. Excel papers, okay. Y equals K X X. We need to go through that? Wait, is that for the shorts or for the actual like lesson? You dash the ones when it's not equal to. So if it was like X is less than 4 or greater than, you would dash these lines, but if it's equal to, then you make it a solid line. Okay. Exponential, okay. I can do that. Cool. Okay, so thank you very much for like tuning in and everything. And thank you for all your suggestions as well. If you have AB equals an arrow in the north direction. So if you have AB equals an arrow in the north direction, if you... Yes, it would be. Yeah, it has to be. It would point in the exact same direction. Are you going to do just higher or foundation 2? In terms of papers, I have foundation papers for Edexcel. Predicted foundation papers. And I think for AQA as well. In terms of actual content, maybe. I haven't had that many people ask for foundation content, to be honest. You're very welcome, Lila. You're very welcome, Evie. Yeah, again, so thank you guys for coming in, and feel free to post suggestions, right? Like, thank you very much, that means a lot. And thank you very much, Mar, for tuning in today. But yeah, feel free to like post suggestions and things like that. You're very welcome, Alia. Like, use these lessons to the best effect. I'm not sure what you guys need exactly, right? Because I haven't met you. So feel free to like say, okay, could you please do this? Could you spend more time on this? Could you do more difficult questions? It's all fine. I'm not going to be offended. Let me know what you need. But otherwise, I will try and go through what I think you guys need. But yeah. Thank you very much. Enjoy your evening, and I will see you next week, hopefully with the new papers ready.